afternoon, respected dignitaries, esteemed guests, and dear participants. It is indeed an honor and a moment of immense pride to welcome you all to this prestigious event, the Golden Jubilee celebration of IIChE Kochi Regional Center and presentation of Outstanding Chemical Engineering Award 2025. Of journey of knowledge, research, innovation, and service to the field of chemical engineering. The Indian Institute of Chemical Engineers, the apex professional body of chemical engineers in our nation, has been nurturing excellence, building industry academia bridges, and inspiring generations of engineers and researchers. It continues to lead with the vision of empowering the chemical engineering fraternity for a sustainable tomorrow. Before we begin today's program, let us take a moment to seek the blessings of the Almighty. I request everyone to join us for the prayer.
ലോകനാഥ സൂര്യനും ശശാങ്കതാരകങ്ങളും പകലും രാത്രി സന്ധ്യയും നിറഞ്ഞ മേഘജാലവും പക്ഷിവൃക്ഷപുഷ്പവും ശലഭരാശി വൃന്ദവും മികവിൽ നിന്റെ സൽകൃതങ്ങൾ വാഴ്ത്തിടുന്നു ദൈവമേ. സകല ശക്ത ദൈവമേ, നമിച്ചിടുന്നു ഞാൻ വിഭോ.
To formally commence the program, we feel privileged to invite Professor Dr. G. Madhu, Chairman, IIChE Kochi Regional Center, to deliver the welcome address and to introduce our distinguished chief guest, Padma Shri Professor Dr. G.D. Yadav. Sir, the stage is yours.
A warm good afternoon to all of you. Most esteemed chief guest of the day, Padma Shri Professor G.D. Yadav. Most respected guest of honor, Dr. P.V.S. Namboodiripad. Esteemed Principal of Government Engineering College, Thrissur, Dr. P.A. Solomon. Dr. R. Anjana, Professor and Head of the Department of Chemical Engineering. Professor N. Manoj, Program Coordinator and Faculty Coordinator of IIChE Student Chapter. And today's star, the recipient of this year's Outstanding Chemical Engineer Award, Dr. B. Lakshmikutti Amma. My colleagues in the IIChE Regional Center Committee, Sri Chandramohan T, Honorary Regional Secretary, Sri M. Sajan and Sri Mohan, Vice Chairman, Mr. Naveen, Attur Naveen, Honorary Regional Treasurer, distinguished guests, esteemed teachers, esteemed members of Indian Institute of Chemical Engineers, distinguished alumni and my dear student friends. Here today we are celebrating the Golden Jubilee of IIChE Kochi Regional Center. This regional center initially established as Thrissur Regional Center. It was earlier called the Thrissur Regional Center, and this was established in the year 1976. So this center has played a key role in the professional development of chemical engineers in the state of Kerala. Founded by stalwarts like late L. Kannappan, Professor M.V. Raghavacharya, Dr. P.V.S. Namboodiripad. He is present here today. He will address us today. Professor P. Shivashankar Pillai, late K. Unnikrishnan, late U. Chandrahasan, and Sri I.V. Subramanian. So they were the founder members of this regional center committee. So this center has entered its 50th year of existence. We remember with gratitude the sacrifices made by the founder members of the regional center. Only two of them are alive now. Dr. P.V.S. Namboodiripad, he was the founder honorary regional secretary, and one more person is with us. He could not arrive here, Mr. I.V. Subramanian. He was technical manager of Travancore Cochin Chemicals Limited. So we remember with gratitude the sacrifices made by these founder members for establishing this regional center. The Golden Jubilee Lecture and the Outstanding Chemical Engineer Award 2025 ceremony have been organized jointly by the Regional Center, Kochi Regional Center, and the student chapter of IIChE in the Department of Chemical Engineering of GEC Thrissur. And as already mentioned here, Indian Institute of Chemical Engineers is a 78-year-old institution. This was established on 18th of May 1947 by Dr. Hiralal Roy, a pioneering chemical engineer in the country. And IIChE aims to spread chemical engineering education and foster the profession. It is the apex professional body for chemical engineers in the country, bringing together professionals from academia, research, and industry. Coming to this institution, Government Engineering College, Thrissur, this is the second oldest engineering college in the state of Kerala. This was established in 1957 and is one of South India's most reputed technical education institutions. The Department of Chemical Engineering of this college, it was established in 1962. The first batch passed out in the year 1967. So initially it had an intake of 40 undergraduate students, and the department has adapted to the evolving demand of the chemical process industry over the past 6 decades. So with this brief introduction, let me fulfill the task assigned to me. Padma Shri Professor G.D. Yadav is a very distinguished chemical engineer of the country, and he is gracing this occasion as the chief guest. He will also deliver the Golden Jubilee Lecture on the topic Towards a Net Negative Future, Sustainability, Climate Action and the Hydrogen Economy. Professor Yadav is one of the topmost highly prolific and accomplished engineering scientists in India. He is internationally recognized by many prestigious awards as an academician, researcher, and innovator. He has served as the president of Indian Institute of Chemical Engineers and has made significant contributions to the growth and development of the institute. I will introduce him detail before the Golden Jubilee Lecture. Sir, on behalf of IIChE Kochi Regional Center and the student chapter of GEC Thrissur, I extend you a hearty welcome. Thank you. Thank you. Our guest of honor today is Dr. P.V.S. Namboodiripad. He is the one and only Keralite to become the national president of IIChE. So he has kindly agreed to grace this occasion as guest of honor. A distinguished chemical engineer and management specialist, he has made significant contributions to the advancement of chemical engineering profession in the state of Kerala. He played, as I mentioned earlier, he played a major role in establishing the IIChE Thrissur, now it is Kochi Regional Center, in 1976 and served as its first honorary secretary. A warm welcome to you, sir. Dr. P.A. Solomon, the principal of Government Engineering College, Thrissur, is offering felicitations to this function. We are fortunate that a chemical engineer is serving as the principal of the college when the Golden Jubilee celebrations of IIChE is held here. He has been kind enough to grant permission for holding this event in the prestigious Gloria Gopi Kumar Alumni Hall of the college and has extended all support to us. A hearty welcome to Dr. Solomon. I am very glad to inform you that Dr. B. Lakshmikutti Amma, she is also an alumnus of this college, and also she served as a teacher in the institution for a very long time. She is a former professor and head of the Department of Chemical Engineering. She will be receiving this year's Outstanding Chemical Engineer Award instituted by the Kochi Regional Center in recognition of her exceptional contributions to chemical engineering education. Let me extend a hearty welcome to you, ma'am. Dr. Anjana R., Professor and Head of the Department of Chemical Engineering, has extended all support to us in organizing this event. She has taken a lot of pains along with her faculty colleagues and students to make this event a grand success. A big thanks and warm welcome to you, Dr. Anjan. Professor Manojan, she Associate Professor in the Department of Chemical Engineering, has been coordinating the various activities in connection with this event for the last almost 2 months. He has meticulously planned everything, all the activities, with the wholehearted support of his colleagues and students. He is a past vice chairman of the regional center. We are really indebted to Professor Manoj for his painstaking efforts. Warm welcome to you, Professor Manoj. Now I should welcome the student volunteers. We have to give them a big round of applause for their sincere efforts in organizing this event in an excellent manner. Let me extend a warm welcome to my colleagues in the Regional Center Committee, Sri Sajan, Sri Mohan, Vice Chairman, Sri Chandramohan, Honorary Regional Secretary, and Sri Atur Naveen, Honorary Regional Treasurer on this occasion. Let me welcome all the esteemed faculty members, the present faculty members and former faculty members of the Department of Chemical Engineering, non-teaching staff and students of Government Engineering College, Thrissur, who have joined this event. And also many senior chemical engineers and alumni of this institution from industry and academia are attending this function. A warm welcome to all of them. And many members of IIChE, past office bearers, they are all attending this function. Let me extend a warm welcome to all of them. I sincerely hope that this Golden Jubilee event will give an impetus to the activities of the regional centers and the student chapter in the months to come. Thank you. Now it's my proud privilege to introduce Professor Ganapati D. Yadav, the distinguished speaker for the Golden Jubilee lecture. Professor G.D. Yadav needs no introduction among the chemical engineering community in the country, but still, for the benefit of the student community, let me introduce him. Is one of the topmost highly prolific and accomplished engineering scientists in India. So he is recognized by many prestigious and rare awards as an academician, researcher, and innovator. He has made significant contributions to many areas of chemical engineering science, like green chemistry and engineering, catalysis, chemical reaction engineering, energy engineering, biotechnology, nanotechnology, and development of clean and green energies. He is an alumnus of the prestigious University Department of Chemical Technology, University of Bombay. Now it is Institute of Chemical Technology. He was the founder, Vice Chancellor of the Institute of Chemical Technology. This UDCT was made deemed to be university, and Professor Yadav served as the first Vice Chancellor, Director and Vice Chancellor of the university for more than almost 11 years. Now he is serving as R.T. Modi Distinguished Professor and Tata Chemicals Darbari Seth Distinguished Professor of Leadership and Innovation at the Institute of Chemical Technology, Mumbai. Under his dynamic leadership, ICT made phenomenal progress, having been declared as a Category 1 institute by the Government of India. And he started 23 new academic programs in the institute, 5 new departments, and several centers of excellence, and also established 2 off-campuses, one in Bhubaneswar and one in Jalore in Maharashtra. That Bhubaneswar campus was established with the support of Indian Oil Corporation. He also currently holds the titles of Emeritus Professor of Eminence and J.C. Bose National Fellow. He serves as an adjunct professor at the University of Saskatchewan, Canada, RMIT University, Australia, and also is a conjoint professor in the University of Newcastle, Australia. He was conferred with one of the most coveted civilian awards of the country, Padma Shri. It's the 4th largest civilian honor by the President of India in 2016 for his outstanding contributions to science and engineering. With over his more than 570 publications, the other day I counted in that Google Scholar citations, with almost 21,000 citations and an H index of 72. It might have gone up now. And he holds 137 patents and has mentored 116 PhD scholars. The number will further increase in the years to come. He has been consistently ranked as the #1 scientist in India and number 66 in the world of physical chemistry, and among the world's top 2% scientists by Stanford University surveys for 5 consecutive years. His rare election to the US National Academy of Engineering and the US National Academy of Inventors further highlights his global standing. He has personally won over 125 national and international honors, awards, fellowships, editorships, and several lifetime achievements awards by prestigious industrial organizations. He is an elected fellow of all the science academies in the country and also an elected fellow of the National Academy of Engineering and also a fellow of the World Academy of Sciences, Thrissur. And also a fellow of the Royal Society of Chemistry, UK, Institution of Chemical Engineers, UK, and Indian Chemical Society, among others. And presently, he is the president of the Indian Chemical Society. He was president of Indian Institute of Chemical Engineers, and he is the first chemical engineer to become the president of Indian Chemical Society in its 100 years history. This Indian Chemical Society was established by none other than Acharya Prafulla Chandra Ray and his students way back in 1924. And Professor Yadav is the first chemical engineer to become the president of ICS. And also he is serving as the editor-in-chief of the prestigious Journal of the Indian Chemical Society. It is published by Elsevier now and has a very good impact factor also. So, and he's serving on the editorial board of a large number of journals. Anyway, I cannot read the full list here. So, a hallmark of his research is its focus on industrial adoption and commercialization. Again, it's a hallmark of Institute of Chemical Technology. He was a student of Professor Manmohan Sharma, the legendary chemical engineering teacher and researcher of the country. Padma Vibhushan, Professor M.M. Sharma, he is a fellow of the Royal Society. Professor Yadav sir was his student. So it's a culture in ICT. They focus on industrial commercialization of the technologies that they develop. So he has been, Professor Yadav has been active and successful consultant to chemical and allied industries for the past 35 years in Mumbai, Pune, Ankleshwar, Hyderabad and Vapi, and his interaction has led to successful development of technology. His interaction with the industries has benefited them in terms of process intensification, waste minimization, product and process development. So with this brief introduction, let me extend a warm welcome to Professor Ganapati D. Yadav again and request him to deliver the lecture. Thank you, sir.
Good afternoon, namaskar. I'm indeed very delighted to be here to sit amongst the pioneers of our profession. I still remember Dr. Nambudripad, who was the president of Indian Institute of Chemical Engineers, and he had conducted ChemCon. Correct? You had conducted and I attended first time that ChemCon. I still remember that. Professor Madhu, Professor Salomon, Madam Lakshmi Kuttam, Amma, should I call you Amma? All right, thank you. Dr. Manoj, Ganesh, other distinguished members of the management committee of this regional center, Kochi Regional Center. 4 of them met me during lunchtime. And dear faculty members, students, ladies and gentlemen. At the very outset, let me congratulate the Kochi Regional Center in its new avatar. Earlier it was Thrissur Regional Center, for this spectacular journey. 50 years is a very long period. So you have done it successfully. So congratulations to all of them who have contributed to success of this Kochi Regional Center. And as the former president of Indian Institute of Chemical Engineers, in 2001 I was the president. I was told by many, IIChE is a dead organization. Nobody was interested in becoming the president. And I said, why not? The first thing I did was to establish 52 national awards, 17 ChemCom Distinguished Speaker Awards, 10 awards for students who go for PhDs. In fact, the first check was given by me. Charity begins at home. So there is an award in my name and my wife's name for the best chemical engineering undergraduate student. The person must be good at everything, academics and also other activities. So I hope some of these students from here would be qualified. So one for a boy and one for a girl. So this is the tradition. And believe me, these awards are named after some of the best chemical engineers in the country, whether it is Professor Manmohan Sharma, Dr. Mashalkar, K. Venkatraman, B.D. Tilak, okay, G.S. Ladda. In fact, Professor Ladda said, I have never taught you, why are you making an award in my name? I said, sir, you had come to IICT to examine us for our practicals in final year. And I remember that. So these 17 awards were then NCL, NIRI, CSMCR, CLRI, all these organizations, CSR gave money to institute those awards, which was unheard. So that has changed IIChE. And since 2001, not a single year is there when I have not participated, except 2 occasions when my sons were getting married. Otherwise, all ChemCons I have attended and participated and generated funds, not less than 50 lakh to 1 crore every year for all these years. So that is IIChE. Now, so what happens? This reputation goes to somebody else. So Indian Chemical Society said, we are celebrating 100 years. Why don't you become our president? I said, why me? So they said, sir, we don't have a single penny with us. And we don't have a building, 100 years society. And so I took over. I created 19 awards, and we are going to have a building of 10 crore worth, supported by industry in Calcutta. So professional service is very, very important. You can be smart, you can be all accomplished, but you don't do anything for the profession. It's bad. We also established the Engineering Council of India. Perhaps you know that. IIChE is a founding member of Engineering Council of India. Now that bill will come. So this is the little history of this. And so since I have given a topic, I want to talk on my topic. Will you please my slides on? What happened? Oh God. Make it full screen. Full screen. Slideshow. On the top. Play from the start. Yeah. So thank you very much for honoring me with this Golden Jubilee lecture, Professor Madhu. I know you have been very sincerely following wherever I go. Last 1 month I have been traveling. Only 3 days I was in Mumbai. And from here I am going to Chennai. From Chennai to Nagpur and whatnot. That is what happens. So I want to, okay, this is a net negative future. What is meant by net negative future? We open up any newspaper today, they will talk about net zero. Net zero is net carbon dioxide emission should be zero. It does not mean carbon dioxide is zero, otherwise we will not survive. Whatever carbon dioxide we produce, which is likely to increase the temperature of the globe, should be contained. So there are technologies. So we have contributed a lot to that. So that is one. Then what is meant by sustainability, circular economy, recycle engineering, that I'm going to talk about it. Climate action and the hydrogen economy, and how hydrogen is going to be the most important part of our economy. And I chair 3 committees of the government related to hydrogen economy, hydrogen infrastructure, so I can talk on this with authority. Look at this climate change. On one hand, you have severe drought, and other hand, you have a lot of flooding. You see that this was Pune, Mumbai, Assam, all sorts of places in India. And do you recognize this place? Kerala. So you had drought, at the same time floods. Kerala has also witnessed. And these are headlines from your newspapers. These 2 are headlines from new newspaper. And it is not here. You go to Europe, everywhere it has happened. It has happened across the world. It is not just here. It has happened across the world. So we are going to face a very, tough future. And look at this. India, look at Canada, California. Every year there are fires. Every year. And across US. And there is a very interesting place in California. I will show you, this is what. That is called Death Valley. The temperature is above 50 degrees Celsius. Nothing can survive there. Nothing can survive. So climate change is real. Although the president does not believe in that, it is real. And I tell you something. Supposing the average temperature of your place is 25 degrees Celsius and it rises to 28 degrees Celsius, 80% of biological species will die. They will not have future. Whether you stay in Kashmir or Kanyakumari, the average temperature, if it rises by 3 degrees, that is going to be disastrous for many biological species. So we have to really worry for climate change. And on the contrary, these days you cannot go to Delhi. Flights are delayed, particulate matter, so-called air quality index is between 300 to 600. So I was in Delhi last year, and in the hotel, my host sent me a message, "Sir, do not leave the hotel, you stay there. AQI is 700. Cannot breathe air. So bad." At the same time, well, this is a lot of politics is going on this. One of the reasons is that the farmers in and around Delhi, they burn their agri-waste. They think they can kill the pest, etc., and it will generate carbon and they will have better crop. And the particulate matter goes about 2.5. So it is very, very bad. How much they are burning? 100 million metric tons of agri-waste. We are talking about increasing farmers' income. Why are they burning it? So I will tell you idea how to increase farmers' income without burning this. And this is 500 million metric tons in India alone. So this, we are contributing to climate change. No matter which city you go, if the air quality index is above 50, it's bad. Up to 100 you can somehow survive. But above that, it is very, very bad for health. You may not recognize that, but later on you will realize it. So this is the latest statistics on this. See, December 14, 2025. In January 20, before the pandemic, the carbon dioxide emissions, the concentration was 410 ppm. And during that particular period, the so-called lockdown, which was announced by Government of India in March 25, we were sitting at home watching old movies or serials and whatnot. Still, we added 2 ppm. Next year, January, it became 412 ppm. And the worst part is that on a particular day, 10th of April 2020, the crude oil price became negative. $10 you had to pay for storing that crude oil. 7 fracking companies in Texas, they abandoned their business and they said there is no future or hydrocarbon industry unless the crude oil price goes above $55 a barrel. So they withdrew from that business. And you know what has happened thereafter. In May 2022, CO2 concentration was 418 ppm. That means the economic activity was restored. Everything was restored. We started going to movies, traveling from here and there. And you see what is happening. December 14 last year, 425. This year is 427. That means we will be emitting carbon. The reason being, carbon as a fuel is a bad idea. And I will tell you how it is a bad idea. Carbon should not be part of our fuel mix. And that is what we are doing. So you see, there is interesting statistics given there. The world refinery capacity is almost 403.5 million barrels a day. In 2020, it was, 97 million barrels a day. And this year, another thing happened. In March 7, the concentration was 430 ppm. That means some action has been taken. In other words, carbon dioxide is going to be a problematic thing. Can we use it as a feedstock? So I'm going to give you some ideas. And if we do not have intervention, that is technological intervention, but policy also, government policy must do that. Otherwise, we'll have a bleak future. The concentration goes up, and supposing it goes to 2000 ppm, which will happen in another 150 years, nothing will survive. Everybody will be dead and gone. So we have to worry today. We have to worry today. So this is, and policy is required. Look at the carbon dioxide emissions, 2020 to 2024. It is increasing, gigatons, billion tons. 34.8. This is only the fossil carbon. If the total carbon you take from all other sources, it is almost 41.6 gigatons. Okay? And so the reason is, ours is a carbon-based economy. We require carbon for survival. We require carbon in the soil for the crops, but we don't require too much carbon in the air. That is the message. And so you see, whether you have fossil carbon, oil and natural gas, these days gas to liquid, crude to chemicals processes, including Reliance, they have announced it. And you look at the coal to gas, coal to liquid processes. And the right-hand side is renewable carbon, so-called biorefineries. Our future, when we don't have any crude oil, that renewable carbon is going to help us to build our biorefineries. So the reason is, use of carbon-based fuel is the real culprit of greenhouse gas emissions. So we wrote an article during that time. Whether it is a renewable carbon or non-renewable carbon, when it is used as a fuel, it ends up as carbon dioxide. So you may say, if I use renewable carbon like bioethanol, you may say it is net zero. But I'm saying that is not a solution for this climate change. I've written so many articles, editorials, newspaper articles. So I will tell you something what is happening. So the net zero and sustainability, this hinges on 10 different points. Some of these points are very, very interesting. I won't go into the details of the research, but I will make you aware as a public. So first is hydrogen technologies. How do you produce hydrogen? What are the means and sources, and what is the cost of that? Then carbon dioxide will be the new oil. So that is the net negative, what I'm talking about. If I capture carbon dioxide from power plants, okay, which is typical every 15% carbon dioxide, and convert that into oil, that means I have to convert into hydrocarbons. Again, hydrogen helps me. The so-called decarbonization of economy, biomass valorization, including waste biomass, municipal solid waste, agri-waste, name it, or purposely grown grasses, I can make use of that as the feedstock. Solid waste management. I do not know how much solid waste your municipality produces. I know the statistics for Mumbai because I live there. 9,000 tons per day municipal solid waste is generated, of which 50% is food waste. So imagine we are talking about hunger, poverty, but 50% we are wasting as food, which goes into the, municipal solid. Plastic, waste plastic recycling. So government says when there is a problem, plastic is polluter, it's the wrong idea. Again, I am telling you that. I am against it. Okay, and I will show you why. Then, water resource management. Just now we talked about, drought and flood, but water is going to be a very important commodity in future. Circular economy and recycle engineering. Chemical engineering will have the best opportunity now in the so-called circular economy. And we are talking about Vikasit Bharat, developed nation in 2047. Nothing virgin will be available to you. Nothing virgin, no material. Whether it is minerals, anything. So you have to reuse. So that is recycle. This is where chemical engineering will play important. Biotechnology. Some of the things will be both bio and chemo. It is not going to be. Some will be physical. And you know the definition of chemical engineering. Some simplest definition of chemical engineering is the applied science which is based on red processes, chemical, physical, biological, including nuclear. And it is always talking about sustainability, but students don't know that. We talk about rates, right, per unit time. We want to increase the rate, reduce the reactor volume, or the processing container volume. Therefore, that so-called process intensification comes into picture. And systems engineering. So we look at everything as a system. Only useful things go inside, whether energy or material, useful things go outside. Whether there is a co-product or byproduct, that will be reused, recycled into something else. That is definition of chemical engineering. So chemical engineering is now systems engineering. Chemical engineering is recycle engineering. So look at this. And if you open up any TV, there are sadhus and babas and everybody says, beta, think positive. I am saying think negative. I am exactly opposite. What I am talking about? I am talking about think of negative, not think negative. That is carbon negative energy sources and material neutrality. Like, what is our general habit? Our general habit, if some use is over of any material, we throw it. Like mobile phones, every 6 months the kids throw the mobile phone. Where does it go? Have you seen where are your old clothes going? You don't know that. Because we don't think of the system, we think about ourselves. So, in other words, net negative energy systems and sustainability. This is what it is. So I'm going to talk a little bit about hydrogen technology, carbon dioxide, and waste plastic recycling. So let us look at this. So since he addressed me, my introduction, he said I work on green chemistry and engineering, but I started the first program in India in 1997. And then in 2010, we had a separate program, MTech in green technology. But safer, cleaner, atom efficient. So normally chemical engineers do material and energy balance. Now in this you have to do atom balance. Every atom you have to count where the atom is going. The atom economy means maximum number of atoms from the reagents must go into the final product. That means less waste. That is atom efficiency. So polymerization reactions are 100% atom efficient because everything is being added. So this is what it is. So we can think of this. So BP Energy gave an outlook in 2021, and I've deliberately inserted this slide to show you that what happened in 2020. We emitted as a whole 35 gigatons, billion tons of carbon dioxide. And for the so-called, and I already gave you these numbers, okay, in the previous slide. And for the net zero, this has to be taken down to from 35, now it was almost 41.6, it has to come down to 10 gigatons. That means so much of carbon dioxide from the atmosphere you have to take it out. So the technologies, chemical engineers work on these technologies, energy efficient, economical and what. So that is what is going to happen. So for achieving the so-called net zero goal, we have to take our carbon out of our fuel mix. Really speaking, we should not be using carbon as a fuel. No petrol, no diesel, nothing. It has to be all renewable energy. So this is chemical engineering. Recycle engineering is chemical engineering. Physical, chemical, biological rate processes. Material recycling, sustainability. Can we create a zero waste society? Assuming you eat 4 meals a day and every meal you waste something, there are 8+ billion people now. Even if you assume 10 grams are wasted, calculate how much food is wasted every day. In the rich countries, that is in tons. In poor, so average number is per capita per day is 1.6 kg per day. That's a huge quantity. So what it means? And remember, we are talking about solar energy, wind energy and everything. This was started, the program was started in India and across the world in the year 2000. That was the year it started. These solar panels do not have a life of more than 25 years. Wind turbines also 25 years. So the latest statistics on this, 50 million tons of these used solar panels are lying somewhere. That has to be reused. There are magnets, neodymium, praseodymium, which are required, powerful magnets in turbines. We don't have it. And recently you saw when Donald Trump put some tariffs on us. He did not put tariffs on China because they hold that rare earths. So we have to recover, whether it is lithium or any other thing, we have to recover. So chemical engineering will come to the fore again. And this must be taught to the chemical engineering students. They have a better role, bigger role in protecting our interest as humanity. So otherwise we'll require 3 years if we have this so-called linear economy. So remember, nothing is a waste. That is the concept. Nothing is a waste, no student is a waste. No student is a bad student. Professors must remember this. No student is a bad student. We make the student bad by our attitude. We think we are smart as teachers. Right? Sometimes some professors, they get angry and they say, you are useless. Now it hurts the student. You should never say that you are useless. You are a good boy. Do it again. Give him a chance. Give her a chance. They will do it. Because nothing is waste. So that is a philosophy. Nothing is waste. Whether your waste is solid, liquid or gas, we can convert that into something useful. Okay. So these are the 5 R. First is refuse. Supposing you give me this water and you don't drink it, that means I have saved carbon dioxide. Right? If I refuse it. Then repurpose, the same thing used for something else. Somebody constructed housing out of used bottles in Ladakh. Okay? Or reduce, reuse. That is, the last I have deliberately colored in green. Recycle engineering, and I told you chemical engineering is the new. Recycle engineering is the name of chemical engineering. So, how does it matter? The government policies matter for recycle. What does the government do? Government has a very simple solution. I will tell you that, although my slides are a little later, but let me tell you now only. When government finds some problem is going out of hand, they have no solution, they say ban it. Like liquor, right? Liquor ban. The states where liquor is banned, maximum liquor is sold there. Don't laugh. Isn't it correct? Because people will find ways and means of bribing the officers, getting it under the table, paying bribes. So more is sold. So once I went to a state where they said there is a liquor ban, I don't drink it, so I have nothing to worry. But some members of my committee, somebody came and gave the bottle to him. I said, how did you get it? It is banned here. He said, no, police wala only gave. Imagine, That means they must have paid money. Why it is happening? Why do we ban? The same thing happens with plastic. Plastic ban, right? Your state has also plastic ban. But in the market you see plastic. How many have seen plastic in the market? Raise your hands. Everybody has seen it. So why are they banning it? What is the meaning of that? If that fellow is caught, he will pay bribe and continue his business. So, and our government will say, 50 micron above plastic is allowed. Do you go with a metering gauge there to measure whether it is 50 or 5 or 49.5? That means the policy, whosoever designed the policy, they have not thought of practicality. The policy must be practiced by the commoner, not by the educated. Educated, normally people cite example of Singapore, that nobody is throwing, there is no. Why they don't cite example of India? Because even at the airport, you go, there are bins, 4 or 5 bins are there. Do you read it? Some color is there, right? Blue, red, black. You look at the bin there, wherever the previous person had dropped, you drop there only. Wet and dry garbage. You don't know what it is. You drank tea. Is it wet or dry? You don't know. So wherever they put, you put it there. That is what it means, policy. In the case of plastic, I suggested this to Maharashtra government. Even I have suggested to the central ministry also that we are using digital economy. We are using barcodes on every plastic article, irrespective of shape, size, weight, length. Put 20 rupees deposit. Supposing there was a 20 rupee deposit on this, or the milk pouch. Best example is milk pouch, right? The housewife is so good in taking the last drop of milk. She will put additional water, shake it. Because she knows milk has value, not the plastic. Then she will throw the plastic. Supposing there was a 20 rupee deposit on that pouch, she would have kept it nicely. Housewife will never throw the newspaper. She collects it because she knows it is radhi, waste paper. Somebody will come to your home and you get money, right? Sometimes housewives sprinkles water on it to increase the weight. Correct? And because she knows it is wet. So if she was told that the plastic bag also has a value, refund of 20 rupees, she will collect and give it, and there will be segregation of plastic at source. Because all these waste management technologies, segregation costs 80%. You are chemical engineers, you know that. So you have to use machinery to segregate into different things, whether it is plastic or metal or glass or whatever. Policy. And another best example, why do you throw it? Because it is free. You throw things because they are free. Nothing free is appreciated in the world, including advice, free advice. You know what happens? Go to any marriage or a party, birthday party or whatever. The chefs are very good at making food of different colors and taste. It looks so good from outside. I don't know. Malayali food, Telugu food, Tamil food, Punjabi food, all sorts of food, right? Thai food. So you go there, you see, you have never eaten that, so you take a bigger plate. And you put all the things there. And then you don't like the taste, so throw it. In marriages and parties, more food is wasted because it is free. Supposing, I am giving this advice, some of you may be getting married or your kids will get married soon. Put another bowl. In front of each dish, put a bowl and say, Madam or Sir, put 100 rupees in this bowl before you touch that dish. I can assure you here, your wife will not allow you to touch it. Because you never eat at home. Just because it is free, you take it. And at the end of the program, you give this money to the bride and groom. They will be happy. Food will be served. So nothing free is appreciated, particularly in India. Right? So incentivize. So we have to incentivize people So government policy matters. In every decision, society changes by government policy, and practical incentives matter, not incentive. We say ban, I ban it. Still you use it. Correct? Still you use it. Have you ever seen a police wala before the signal? He is always after the signal. Why he cannot stand before the signal? Because he wants to make money. You know that you are going to break the signal. So the incentive has to be such that, so you can see that. So this is what it is. Circular economy is what systems engineering approach, net negative useful products exist. Everything else is recycled. Like you have studied esterification reaction. Water is a co-product. You cannot change water. It will be always there. Unless you change the route. So you see that? Carbon dioxide, waste biomass, plastic, municipal solid waste. Everything becomes a source. All waste becomes the source. And that is our so-called, systems engineering approach. Now I come to hydrogen. Because hydrogen is talked a lot, and I work in this area. Brown hydrogen, gray hydrogen, blue hydrogen, turquoise hydrogen, green hydrogen, pink hydrogen. Hydrogen is colorless. So why these colors are given? Because they use energy which is not clean. Okay? For example, gasification, coal gasification, brown. 19 tons of carbon dioxide per ton of hydrogen is produced. Go to gray, which is steam methane reforming. All refineries use this. That is 11 tons of carbon dioxide per ton of hydrogen. Blue hydrogen means what? You capture part of the carbon dioxide, 90% if you capture, so it may be CCUS, carbon capture, utilization and storage. If you that becomes blue. Go to turquoise, means pyrolysis of any hydrocarbon, particularly natural gas. It leads to carbon and hydrogen. That is zero carbon. Green hydrogen means electrolysis or thermochemical processes. Then pink hydrogen means the energy source, there is renewable energy, solar, wind, okay. You can have hydro, nuclear. So the nuclear when used becomes pink. And white hydrogen is which is occurring naturally. Okay, so these are the colors. And now somebody else in the state of Texas, they have added another color to this, gold hydrogen. As if we are not happy with one. He says gold hydrogen. That is based on policy. So you see that all these things are very, very important. And in these two, in future, when we talk about Vikasit Bharat, only two will be important. That is the blue hydrogen and green hydrogen. And what is there are different estimates by different agencies. In European Union, there is an agency called Hydrogen Council, International Energy Agency, Energy Transition Commission. See, what are their predictions? All of them predict different ideas. That number varies between 287 to 813. Today we produce 130 by million metric tons of hydrogen, of which 1/3 used by the refineries. Refineries use a lot of hydrogen. Okay? So then the fertilizer industry, then the steel industry and all that thing. You can see that. So total hydrogen demand varies depending on who is predicting. But what is prediction? It is going to grow. Hydrogen will be growing. And so there are various means by which, so wherever you have hydrogen source, whether it is water, HCl, H2S, whatever, that can become hydrogen source. If there is a carbon, that also becomes hydrogen source because you are using water with that. So more hydrogen comes from water and the oxygen goes as carbon dioxide. That is what happens in all these courses. So I call this new trinity, Brahma, Vishnu, Mahesh. Solar, wind and hydrogen. And I give hydrogen the prime number, prime Devas. Devas is a Sanskrit word meaning deity. And hydrogen is going to be the savior of the world. Because hydrogen gives me both materials and energy. Hydrogen is an energy carrier. Others don't give me that. So you can see green hydrogen, and this is Now this is where entire world is focusing on now these days. Entire world, including government of India. So see this. Look at the energy scenario. What is happening? By 2050, 73% of the energy will be renewable. And that number will be 49,000 terawatt hours. My advice to our government is we should have at least 20% of this energy produced by India, and we should export it so we have a lot of money. Right now, we are dependent on crude oil and somebody else is screwing us. Right? All these countries, we are having crude oil. First, Middle East did it. Now, USA is doing it. Hydrogen, you can have your own hydrogen. If you have solar energy, wind energy, whatever. So we should produce 10,000 terawatt hours. Our goal is what? By 2030, we want to make 5 million tons. That number will change. So you see, and there will not be any crude oil by 2050. So, so any carbon source. So this work we did in our lab, bioalcohols, methanol, ethanol, ethylene glycol, butanol, glycerol, all these things can be used, and we proved it. We got many patents, and we have developed technology. So we can see that. But what is interesting, when everybody is talking about electrolyzers, I am talking about something different. That is called the thermochemical water splitting for green hydrogen production. And this work of mine is supported by ONGC Energy Center. They have been associated with me for the last 17 years. So you see that is, we call this copper chlorine cycle. And if you see this copper chlorine cycle, it is a complicated, flow sheet. Complicated flow sheet. But as chemical engineers, we have not developed any chemistry. It is all chemical engineering. We did that. And our idea was to improve efficiency of each and every process. Do not allow any energy to go waste. So we did many work. We have published, we got many patents in that area. And so you can see that this is our pilot plant. We built it in Goa. Now I have shifted this pilot plant to Panvel in near Mumbai. And so in the next couple of years' time, we will be selling this technology across the world. Okay? So this pilot, 6 of my students work for their PhDs on this. And so very interesting problem. And interestingly, so this is, this particular technology, we are saying we can produce hydrogen in less than $1. And right now the cost is anywhere between $4 to $9. $4 to $9. We are saying that. Only time will tell whether we can do it. So you see, so in USA, Department of Energy has given this target, 111. India is a cricket-loving nation. Do you know what is 111 in Test cricket? Nelson's eye. That means you can get out. If you are scoring 111, the batsman is literally, his confidence is shattered. He thinks he will get out because it's superstition. So 1 kg hydrogen in $1 in 1 decade, that is 2031. This is US, and they are giving $3 per kg incentive. So I told our government also, we should give incentive to our producers. We should respect our industry. Yeah. So we can do that. This is, gray hydrogen in refinery is about $2 to $2.5. So we see that we can do this. So, this particular slide shows what we did in ICT in my lab. So we use solar energy. We have molten salts, which we have patented. We store energy in molten salt. And we have this copper chlorine cycle. We produce hydrogen and oxygen, and we produce variety of things from carbon dioxide to methane, LPG, sustainable aviation fluid, from biomass waste and plastic. We can produce hydrocarbons, methanol, dimethyl ether, formic acid, higher alcohols, all sorts of things we have done. Okay? So this slide is my work in IIChE Mumbai. Okay? And at the same time, so-called green ammonia. Once you have, hydrogen, green hydrogen, take nitrogen from here, either cryogenically or pressure swing adsorption, coax it, and you get ammonia, which is green. That Wherever hydrogen is used, ammonia can be used, whether it is IC engine, internal combustion engineer, boiler, fuel cells, whatever. Or you split ammonia there, so ammonia once again has come to fore. We did not build new plants, ammonia plant, Dr. Nambudripad would know that. For almost 30, 40 years we did not build. And now we are saying, do it fast. So government policy matters everywhere. So this is what it is. So this comparison I did based on coal, natural gas. So you can see that comparison of hydrogen production costs based on the data which are available in open literature. You see that? Coal, natural gas and renewable electricity, see? So the last one is my process, which is a thermochemical process. And this was named in the Rajya Sabha by Honorable Nitin Gadkari. He named me that we have done, because he had seen our plant. He said that we have done this work. So I feel very happy that is almost 2 years ago, this was mentioned in Rajya Sabha. Okay, so this is what we did, integrated technology, complete solution for green hydrogen and carbon dioxide refinery. So what we did, this is it. So carbon dioxide to methane and hydrocarbons, we have done it. So we can make the so-called SNG, hydrogenated methane, which is used for our buses. Okay, and we have expression of interest from 3 companies. Okay, that is one. Secondly, carbon dioxide into dimethyl ether. Dimethyl ether is a very good substitute for LPG, natural gas, okay, or diesel. So we produce, and in fact we have transferred this technology to Godavari biorefinery. Just a couple of weeks ago we inaugurated that plant, and the bigger plant will be built. So they have about 450 tons of carbon dioxide coming from the fermenters. All fermenters produce carbon dioxide. So you may say it is carbon neutral, but I said why not valorize it? You can get carbon credit. So that is what we did. So all sorts of catalysts we developed. I won't go into the details of that. Then carbon dioxide to methanol, 5 tons per day plant we are building now. So you can see that this is another area for methanol, green methanol, etc., what people talk about. And this, the next part here is this. Why methanol? Because Niti Aayog has a policy on methanol. That is so-called methanol economy. Just push. Okay, go to the next. Formic acid also, here it is. So this is, once you have methanol, you can produce all sorts of chemicals. Now we are doing, carbon dioxide to ethylene in my lab. But of course we go through methanol in that. So you see, I wrote a very big paper on that. Then we got patents also. Next, So dimethyl ether can be also used. So the future industry will be methanol, dimethyl ether, which will come from carbon dioxide. Okay, so once you have hydrogen and carbon dioxide, see how many chemicals we can produce, right from acetic acid, monomethyl acrylate, MTBE, DME, gasoline, biodiesel, name it, everything I can produce. So chemical engineering will come to fore, right? So chemical engineers should not be disappointed. Your courses, you should get more number of students next year, Madhuji. And I can play with carbon dioxide and make all sorts of chemicals. That is purely organic chemistry. We can make that. But I tell you something else. Next slide will tell you that. Carbon dioxide refinery, there are 6 processes by which I can convert carbon dioxide into a variety of things. So carbon dioxide refinery is a new concept. Okay, carbon dioxide is not just greenhouse gas, but we will make refinery out of it. Okay, that is the idea. So there is chemical catalysis, biocatalysis, thermocatalysis, plasma, electrochemical, photochemical. And so you see, carbon dioxide becomes a feedstock. Carbon dioxide becomes a feedstock for new types of industries. So another interesting part. We say put ethanol or bioethanol in petrol or diesel, because why do we do that? as a scientist, I'm against it. But policy, yes. You know why? Because we want to increase the income of the farmer. We import so much of crude oil. We can reduce that import if we use bioethanol and mix it with petrol or diesel. That is the policy. Yes, for some time it should continue. But as a chemical engineer, what I believe I have shown here. 1 kilo of crude oil gives me 32 megajoules of fuels plus 0.2 kg of chemicals. This is a typical refinery. But go to 1 kilo of biomass, it will give me only 6 megajoule of energy or 0.8 kg of fuels, chemicals rather. So what is good? So we did this calculation based on 97.4 million barrels. Go to the next bit. Yeah. You see that typical 97.4 million barrels refinery means 215 barrels per day of fuel. If I have 100% biomass, it gives me only 10 barrels per second. But if I convert everything into chemicals, it is 320 barrels per second. So what is good? Common sense tells me that making chemicals is a better idea than burning ethanol as a fuel. Okay? So I can do all sorts of things with biomass. Okay, go to the next. And I have shown some of these things. For example, bioethanol. I can make 11 major chemicals and 19 specialty chemicals from ethanol. Okay? So instead of burning it, I can use it as a source. So my industry will be based on ethanol. Okay, next. So this is important thing. Carbon should not be burned as a fuel. That is the message I am giving you. So energy should come from renewable energy. Okay? So, and I also told you about single-use plastic ban. It is a bad idea. Go to the next. Okay. Plastic pollution, whatever polluted till today, including microplastic and future. If I recycle it, depolymerize it, I get hydrocarbons. So that is what I am going to tell you. Next. So newspaper recycling and the housewife. I have told you the story already. Go to the next. Go to the next. SUV pollution is due to the free and cheap availability of plastic articles. That is the reason. Encourage recycle at source by a sizable deposit policy. Next. So, how do we put end to plastic pollution? Chemical recycling. Once again, chemical engineering. Go to the next. So, you see how many ways by which I can make it monomers, you can upcycle, downcycle, recycle. Whether you use plastic in road making or somewhere else, it will be used. But go to the next. So you see, plastic recycling, I can do pyrolysis oil, gas processing, refining, all sorts of things I can do with plastic. This is all chemical engineering. Go to the next. So government policy matters. As I told you, anything free is bad. You give free mass to the student, he will not attend your classes. Why should he attend? Somebody who doesn't attend gets the same marks as somebody who attended. He is not going to attend. Right? Go to the next. And it will promote digital economy. That is our UPI, right? That is our policy. You don't have to give money. Somebody comes to your home, collects it, because you are lazy, you don't go to the market, he will come and take 5% commission and return your money back through UPI. Go to the next. So we can see that plastic can be recycled, depolymerized and all. There are ways and means of doing that. We have done a lot of work in my lab. Still my PhD students are working on that. Go to the next and I will show you this. This is hydrothermal processing, chemolysis, pyrolysis, gasification, waste plastic recycling. Go to the next. You see that? We showed variety of chemicals, these plastics. We use and recycle them by using hydrogen is the most important. Go to the next. So you see that the PET, we showed it PET hydrolysis. Go to the next. Yeah. Well, I won't go into the details of the engineering and kinetics and all. I'll go to the next, but yeah. So this we developed some new theory also. It is not just we did technology, but we developed new theory also. Go to the next. Yeah. hydrogenolysis is the better solution. You don't have to segregate plastic. Even if it is a mixture of plastic, we can convert that into hydrocarbons. Go to the next, and that is what it is. So, hydrocracking, hydrodenitronization, hydrodesulfurization, dehydrochlorination, all these things are there. There are 8 processes in refineries where hydrogen is used. That is why they have the steam methane reforming. I can use this hydrogen, same hydrogen, for getting hydrocarbons. That becomes my feedstock for industry. And the remaining things I already know. H2S handling I know, ammonia handling I know. Go to the next. So you see that waste plastic, this is from one of the research papers I wrote, I can take any plastic and play with that. Okay, go to the next. So this is so-called petroleum refinery versus biorefinery. Benzene, toluene, xylene, butanes, that is petroleum refinery. Biorefinery is exactly opposite. We have so many chiral centers, nitrogen, sugar, whatnot. Go to the next. So one is a functionalization, another is defunctionalization. Go. So you see, so the farmer's income can be increased if we encourage. For example, what I will do? I will tell the farmers, I will not give them just free money. I will tell, okay, collect your aggregates, densify it, make pellets. One pellet, 1 kilo is 6-7 rupees. I will give you 10 rupees. So wherever you are collect, I will collect it and process it, make chemicals. Go to the next. So that will be cooperative society. So you see how many things I can make, multiple product streams from this so-called cellulose, hemicellulose, lignin. These are very important sources. So no matter which agri-waste you have, we can do that. Go to the next. So see, go to the next. Yeah, you see these are the cellulose and hemicellulose structures. 14 different catalytic processes I can use to make chemicals. So nothing is waste. Go to the next. Yeah. So you see in the top, cellulose, hemicellulose, C5, C6 sugars. I tell farmers many times, I don't need sugar cane. I can make sugar from this. Okay, C5, C6 from hemicellulose. Then you see on the bottom, so top is hydrogenation, bottom is oxidation. In other words, it is water splitting. Hydrogen and oxygen. All these will be my future of so-called climate action. Go to the next. So you see, for example, glycerol, which is produced as a co-product of biodiesel, 23 chemicals I can make from that. Otherwise, biodiesel cannot compete with petrodiesel. It cannot compete. And 10% by weight, this biodiesel is produced. Go to the next. So you see, same is the case with furan. So tomorrow feedstock will not be benzene, toluene, xylene, it will be furan. So furan-based chemistry. We've done a lot of work. This is from one of my research papers I wrote. Go to the next. Now, hydrogen, people are worried. They think the hydrogen bomb. No. It is deuterium. Hydrogen is safer than petrol and diesel. 14 times lighter, and we have better sensors available now. So we don't have to worry for hydrogen. Go to the next. So this, there was a chemistry for the future conference in Stockholm where I represented India and we signed this declaration. Go to the next, and you can see that I was the second person to sign that declaration. And this is Nobel laureate Ben Fering of Netherlands. He was also there. And 30 people from across the world, we signed this declaration. How chemistry and chemical engineering should be taught in future. This is what it is. Go to the next. So, last 2 slides. 5R. That is green economy is what? Bioeconomy, production of biomass, bio-based economy, circular economy, green hydrogen, carbon dioxide, waste plastic, all those things become my sources of feedstock. Go to the next. So net negative is the goal, net zero is not the goal. That is what I've been telling. Carbon dioxide will not be a liability but asset. Green hydrogen will be the savior of the world. This is where government policy matters. No matter what you do, if the policy is not right, you may have the best technology. It will not work because people have to be convinced about the policy. Go to the next. So I must acknowledge a lot of my students who have worked with me. over the years, and they are still there in my lab. They're working with me. So this work is dedicated to them. Thank you very much. And if you have any questions, I'll be more than happy to answer. And the purpose of my lecture was also to entice young chemical engineers not to leave the professor and become some junkie, do some management and work in a bank. That is not the purpose of engineering, right? Engineers must produce. Engineering by definition is making money. Yeah, no engineer, right? You are upscaling everything. So engineering by definition is making money, adding to the economy. Any questions from young students there? Okay. Thank you. Now we have to give awards to the awardees, right? So it is better that they come here. You have a question?
No, sir.
Okay.
So you may kindly remain on the stage and be seated. I must say, what a pleasant and interesting way of presentation, sir. Thank you so much for your enlightening session. The whole lecture was definitely a profound session which provoked many perspectives in the field of sustainability, climate action, and hydrogen economy to all the guests and of course, yes, us, the chemical engineering students. We are extremely indebted to you for taking much effort to bring out this thought-provoking discourse. Once again, let's all give it up a good round of applause to Padma Shri Professor Dr. G.D. Yadav sir for that very insightful lecture. And this is IIChE Golden Jubilee Lecture and the Outstanding Chemical Engineer Award Ceremony 2025 organized by Indian Institute of Chemical Engineers, Kochi Regional Center in association with IIChE Student Chapter of Department of Chemical Engineering, Government Engineering College, Thrissur. We now proceed to the next key highlight of the day, the Outstanding Chemical Engineer Award Ceremony. For that, I invite the following dignitaries to kindly join us on the stage. To start with, I invite our distinguished Padma Shri Professor Dr. G.D. Yadav, past President IIChE, Emeritus Professor of Eminence and former Vice Chancellor, Institute of Chemical Technology, Mumbai. Dr. P.V.S. Namboodiripad, the former National President of IIChE, distinguished Indian technocrat, management leader and quality expert known for his significant contributions to Keltron and Managing Director of Hindustan Latex. Next, I welcome Professor Dr. P.A. Solomon, Honorable Principal of Government Engineering College, Thrissur. Let me also welcome the rest of the dignitaries. May I request Professor Dr. G. Madhu, Honorable Chairman, IIChE Kochi Regional Center and retired Professor and Head of Department of Fire and Safety Engineering and Division of Chemical Engineering, CUSAT. May I also request Shri Chandramohan T, Honorable Regional Secretary, IIChE Kochi Regional Center and Deputy Manager, Production of HOCL Kochi. The dignitaries will be accompanied by Dr. R. Anjana Ma'am and our Program Coordinator, Professor Manoj N. Once again, a hearty welcome to all the dignitaries onto the dais and also to all the officials of IIChE Kochi Regional Center and all the faculties of Department of Chemical Engineering, Government Engineering College, Thrissur, and also all the student community. We now request Dr. G. Madhu to introduce our guest of honor, Dr. P.V.S. Namboodiripad, the only Keralite till the date who had the privilege of being National President of IIChE. So please.
It's my proud privilege to introduce Dr. PVS Nambudiripat, who has kindly agreed to grace this occasion as guest of honor. As mentioned here, he is the only Keralite to occupy the position of President of IIChE in its 78 years history. Dr. PVS Nambudiripat is a distinguished chemical engineer and management specialist and has made significant contributions for the advancement of chemical engineering profession in Kerala. I have already mentioned that he was the founder honorary secretary of IIChE Thrissur Kochi Regional Center. And he has consistently advocated for the involvement of chemical engineers in regulatory bodies like state pollution control boards, then public health engineering department, so-called Kerala State Water Authority. And also, he has been a strong opponent of gender discrimination faced by women chemical engineers in industry. At one point of time, lady chemical engineers were not accepted by the industry. Only during the second half of 1970s, chemical industry started recruiting women chemical engineers. So Kerala, a team led by Dr. Nambudiripat sir, they approached the government and fought with the government and so that lady engineers are absorbed in chemical industries, central as well as state public sector undertakings and other bodies like the state pollution control boards and other departments. So now coming to his educational background, he is a graduate in chemical engineering from the very prestigious Jadavpur University. Jadavpur University is the first university in the country to offer a course in chemical engineering, way back in the year 1921. Earlier I told you about Dr. Hiralal Roy. He is the founder president of Indian Institute of Chemical Engineers. When IIChE was formed in 1947, Dr. Hiralal Roy was the president. He was unanimously elected president. And he is rightly known as the father of chemical engineering in India. And he was a professor in the National College of Education and National College of Technology in Kolkata, the forerunner of Jadavpur University. So our Nambudiripat sir was an alumnus of this institution where Indian chemical engineering evolved. So that is the story. He graduated from this Jadavpur University in 1958 and then he worked in industry for a while and later joined Indian Institute of Technology, Bombay for his Master of Technology degree, and he's obtained his MTech in Chemical Engineering in the year 1963, after working in industry for 2 or 3 years. So he belonged to the first batch of MTech of 2 years duration. Earlier, master's degree programs in engineering was of only 1 year duration in IITs and other universities. So he belonged to the first batch of MTechs with a 2-year duration. Later, he obtained his PhD in coast engineering from the University of Kochi while working in industry here. He had a long stint at Periyar Chemicals in it's a place, it was located in Edayar. It was a major producer of acetic acid, this Periyar Chemicals. He was works manager, served as works manager and headed that unit for almost 20 years. And in the year 1984, he was elevated to the position of chairman and managing director of Hindustan Latex Limited, Thiruvananthapuram. He turned around that organization. This unit started making profits while he was the chairman and chief executive of this Hindustan Latex Limited. And while he was in Thiruvananthapuram, he established the Trivandrum Regional Center of IIChE, and they conducted an annual session, ChemCon in Trivandrum, in the year 1989. Prior to that, in the year 1978, while he was in Kochi, he organized another annual session, 1978. That is, so these are the only two ChemCons organized in the state of Kerala. And Namboodiripad sir was part of both these ChemCons in 1978 and 1989. After that, we could not organize an annual session of IIChE in Kerala. In 1984, he left Hindustan Latex Limited and, in 1989, he left Hindustan Latex Limited and joined Apollo Tyres Perambra as chief executive and continued there till 1994. Then he served as business advisor to Al Raji Petrochemical Group in Saudi Arabia and was instrumental in establishing their petrochemical ventures. He participated in numerous committees and boards established by the government. He was a key member of the State Committee on Science, Technology and Environment, Government of Kerala, for an extensive period of 11 years. Now this agency is known as KSCST, Kerala State Council for Science, Technology and Environment. Earlier it was called STEC. So he was part of the executive committee of STEC for a pretty long period of 11 years and played an important role in the formulation of science and technology policy of the state. Additionally, he served on the board of the Agency for New and Renewable Energy Research and Technology, the very popular ANERT. He was on the board of ANERT during its initial years, significantly contributing to the development of Kerala State's policies regarding non-conventional energy and energy conservation. He has been the recipient of various awards and recognitions. In 1988, he was honored with the esteemed Management Leadership Award from the Trivandrum Management Association. Later, he was awarded the Management Leadership Award of the Kerala Management Association. And furthermore, in 2008, IIChE Kochi Regional Center honored him with the Outstanding Chemical Engineer Award. So with this brief introduction, let me extend a warm welcome to P.V.S. Namboodiripad sir once again and request him to deliver his lecture, talk a few words to this august audience. Sir, please.
Firstly, really good afternoon to all of you, all our fellow professionals and students. Well, I will tell my age when I end. Well, I was so much what should I say? I was in another world after hearing Dr. Yadav's talk. It may be nothing for him because he was several much more bigger places he might have presented this. But there was so much attracted me or so much interested. that really I didn't know how much time it has taken, really. And I was telling him, being a national president, well, this should be included a part of the curriculum in all chemical engineering in India through IIChE as in one semester, one paper. This is my humble request to Dr. Yadav. Because otherwise, nobody is bothered. Don't think that government will come and do something. Your ACT will come something. UGC will come do something. See, our professional institute has to contribute, or what we are contributing. See, every year our national president comes and goes. What's his contribution to the profession? Yes, you have done fantastic. You have got 127 patents. No, you see, the government is honored with Padma Shri. So now I humbly ask you, contribute to our institute, our profession. Because these type of things are most important. They should really study. Now the second level, third level and details, fantastic that he himself has told, this is chemical engineering. Nobody knows. See, actually I had a lot of cooperation with the institute and industry. When I was in industry, if I have got any little success in industry, that is due to the collaboration between institute and industry. I believed in it, and I tapped it, and I got the result. And I respect even now that very seldom the CEOs or MDs, CMDs does from the industry. But I really tasted it. So these type of subjects are to be given. Even number of PhDs can be developed from this, any of these topics you take, and I am telling you the faculty of this engineering college. And occasionally consult with him. Or go for a week, or go for a couple of days, meet him. You know, when, at that time when we were in Bombay IIT itself, UDCT is a mark different, a shade different, a shape different. So, get the advantage. And I should really appreciate who prompted to contact Dr. Yadav and get him. And I really, a big salute him first. See, it was a really, after all these countries traveling and working, you know, it was really a feast for me. And other thing which I want to say that most of the things, actually Dr. Madhu has told, but chemical engineering was not in this shape when we were there. And I don't want to repeat and all these things. So, first 4 years course in chemical engineering started in Jadavpur. And at that time, this intermediate and all other things, at that time, one of my physics professor told, go, this is a very developing branch. And I was not knowing anything at that time. And he told, go to chemical engineering, and the best institute at present is Jadavpur. You go there. If you get admission, well and good. And like that, I went to Jadavpur. It was and another important thing, since Dr. Yadav has mentioned as well as Madhu also told, I had the proud privilege, or I was so lucky that Dr. H.L. Roy has taken some classes to me in 1955. And Dr. T.K. Roy. And actually, when I was CEO for about years, T.K. Roy and his missus came as my guests here in Chalapudi for some treatment and all other things. So I had the big privilege being a student of them. And Dr. H.L. Roy was fantastic. You cannot imagine the concepts he presents, not just equations and all other things. It's a very different way of teaching. And occasionally here some of the people know, when I was coming for Vivasi, I never used to ask much chemical engineering to any of these people. I say, what is entropy? Then they will say integration, zero to infinity. So I don't know, I don't want that. What you understand? Very seldom I get the answer. And similarly, I ask, what is pressure? Oh, F by A. I don't know. What do you understand? What is physical concept? Because engineering is an application of basic science. Since I was in industry, if you want to apply that, you should know fundamentals. You know the basic physical concept of that. Otherwise, you can't apply that. It's a knife. If you want to cut it, you should know you have to hold like this or like this. No, you should know about that. Because I really tested it. So when I ask such questions only, then I very interestingly I use, what is Prandtl number? Immediately he will give the equation. So I say, no, I don't want. Physically, what's the purpose or what's the meaning or what you understand from the Prandtl number? No. In my 11 years, a very good answer has given one Mr. Krishna Kumar, then he went for PG to UDCT. Even now I remember. Only a couple of students have given a really very, very intelligent answer. So, calling people like from industry, people might have told, oh, he doesn't ask anything much chemical engineering for Vivasi. That is all you people's job, not my job. So I know why how I can use a chemical engineer, where he is capable of that, instead of teaching him 1 year. So these are some of the main points which I wanted to really point out. And then chemical engineer situation was also, status was also very bad. And even now, I don't know, the chartership, did we get it?
No, it is being considered now.
See, 50 years we are trying for a chartership. Why chartered? You know, that is another point. Now, actually Dr. Madhu, he always writes, Dr. Madhu, Institutes of Engineers. Don't misunderstand me. See, because he's a chartered engineer. So we are not chartered. And what do you mean by chartered engineer? See, actually, Institutes of Engineers has been chartered when in the British Parliament they have brought, British Parliament has passed. Only 2 institutions, according to me, if I am wrong, you correct me. Another is chartered accountancy. And I used to ask some of the CA people, why this chartered? They don't know. I am telling you, very recently I asked one of the fresh chartered accountant, passed a girl, he went for chartered accountancy on my advice. Then I told, what do you mean chartered? She said no. And first chance, with high ranks she passed. And she will be a good chartered engineer also. But we don't know what is chartered. Because even for certifications and other things, a lot of things we want chartered engineer. Even now, either you remove that bloody chartered, we don't want this 450 people, 375 people are criminals in parliament. And they are passing this. Why we want to have a chartered? This is the whole problem with me. I don't want what somebody else is doing. We want to do ourselves. Why we want to have chartered? Please don't try anymore if you are not God. If you are not God, don't try for this, because there is no meaning. You try for removing signature by chartered accountant. The chartered you try to remove from there. And you know, one of the chemical engineers was IPS in Kerala. Actually, I interviewed him in the final. And he has to take another degree to go for IPS. At that time, it was chemical engineering was not allowed for IAS or these things. Just imagine. It was not allowed. No. Later, it has been, I heard, I don't know. At that when we passed, it was not allowed. A BA economics or a logic or a BSc chemistry fellow can appear for IAS. You know a chemical engineer, he cannot appear. See, these are all things which you know. You should know. And these are all the things institute has to really work. And this is, somebody has to point out, this is all not very big things. But whenever you go to either UGC or the concerned authorities or department, kindly try. At least let these people get some benefits. Yes. Even specialized subjects, you are correct. Even medical graduates or engineering graduates goes for IAS, they never take medical or engineering paper. They take Malayalam, history. Is he?
Actually, Dr. Nambudripad, I had tried to include chemical engineering in IAS, and what we found, none of the engineering students, including IIT students who pass IAS, take engineering as the examination. They take history because this year so and so thing happened. That is important. Engineering, if you don't get the correct answer, you are gone. So none of the students are taking engineering for IAS. They are basically engineers, but they are not taking. Therefore, then they said, what is the fun in including additional engineering in that? That is the reason.
You see here.
If they had said, okay, we will have so many chemical engineers, so many mechanical, so many civil, then they would take it. But that is not there in that. The competitive, I have also examined students. That is not there because they don't take. They don't take.
But if you ask me,
that was Home Ministry. Home Ministry was supposed to do it, but then they found that it is not worth it.
Actually, if you really ask me, my concept is this medical or engineering graduates should not be allowed to go civil service. No, I will not take much that. I know. Because Government of India spends almost 8 to 10 lakhs for an engineering student. Not with infrastructure, college, KSEB now, the electricity, extension. Public government spends almost 6 to 8 lakhs. Then he goes for IAS, the Royal or whatever glorious things, and he will say, yes sir, yes sir. And a professional fellow goes become as an administrator in a very, very sad situation. Similarly, medical graduates. See how many lives he or she can save. There is almost 13 lakhs we spend for a medical graduate. So, these are all very important things, and well, now I promise that I will tell my age at the end of the, I am 90 plus. And I came because Institute, Chemical Engineering and Institute, it is in my brain, it is in my mind, it is my heart. I cannot stop it. Because I have spent a lot of my lifetime to this profession. So I came all the way, and then I really wanted to meet all of our fellow professionals, and how is the new professional people, learning stage students. So that's why I have come, and especially I am very much thankful to Dr. Madhu. But the organizers forgot first time that who are the founders, they were not knowing. That's only sad part of the whole thing. Then I had to call them, or I have requested them. I told I want to come. And like that, and of course that was a slip. And I am very much thankful to you. I am highly obliged. Thank you very much to all your blessings.
Thank you, sir, for your thought-provoking words. It is indeed an honor to have you here, sir, and it's a great privilege for all of us witnessing you on this very special event. We now invite Professor Dr. P.A. Solomon, Honorable Principal, Government Engineering College, Thrissur, for his felicitation address on today's event. So please.
Respected President of this meeting, Dr. G. Madhu, President of IIChE Kochi Regional Center, Chief Guest and Distinguished Speaker of the program, Padma Shri Professor G.D. Yadav, past President of IIChE and former Vice Chancellor of ICT Mumbai, Guest of Honor, Dr. P.V. Nambudripad, PVS Nambudripad, past President of IIChE and former CMD of Hindustan Latex Limited. Awardee of the day, Dr. B. Lakshmi Kuti Amma, former Professor and Head of Department of Chemical Engineering, Government Engineering College, Thrissur. Dr. Anjana R., Head of Department of Chemical Engineering, Professor Manoj N., Associate Professor in Chemical Engineering, Sri Chandra Mohan, Office Bearer of IIChE Kochi Chapter. Any problem? Okay. And respected former teachers of GC Thrissur, especially Department of Chemical Engineering, and eminent alumni members of Department of Chemical Engineering, and dear students and other faculty members. It is indeed a matter of great pride and privilege for me to stand before you in this august occasion of Golden Jubilee Lecture and Outstanding Chemical Engineering Award 2025, coordinated by IIChE Kochi Chapter jointly with the IIChE Student Chapter of GC Thrissur. I take this moment to extend my heartfelt congratulations to my beloved teacher, Dr. B. Lakshmi Kuti Amma, for receiving this highly prestigious and well-deserved honor of Outstanding Chemical Engineer Award for the year 2025. Dr. Lakshmi Kuti Amma has made remarkable and long-lasting contributions to chemical engineering education. As an inspiring teacher, committed academician, and able administrator. She has shaped generations of chemical engineers through her clarity of thought, depth of knowledge, and constant commitment to high academic standards. Her valuable contributions include co-authoring 3 highly regarded textbooks, Stoichiometry and Process Calculations, Mass Transfer Theory and Applications, and one latest book on waste management for small towns in developing countries. These works continue to serve as valuable references for students, teachers, and practicing engineers alike, reflecting her strong commitment to both fundamental and societal relevance in engineering education. Hearty congratulations, madam. As head of the institution for this prestigious event, it gives me immense pleasure to extend a warm and respectful welcome to our chief guest and distinguished speaker, Padma Shri Professor G.D. Yadav sir. So your presence is a matter of great honor for the department and the institution. It is also happy to welcome Dr. P.V.S. Namboodiripad, President of IIChE, and whose leadership in industry is truly inspiring. I sincerely thank Dr. Madhuji. I should call him Madhu sir. I usually call him Madhu sir. So I have to thank Madhu sir, President of IIChE Kochi Regional Center, for selecting or choosing GC Thrissur as a venue for this program. Thank you, sir. Once again, I congratulate Dr. B. Lakshmikutti Amma, my beloved teacher, and wish her good health and continued inspiration. Thank you so much.
Thank you, sir, for your uplifting and valuable words. Now, we move on to the most awaited Outstanding Chemical Engineer Award 2025 ceremony. With all the privilege, let me announce that this year, IIChE Kochi Regional Center is honoring Professor Dr. B. Lakshmikutti Amma, the former professor and head of Department of Chemical Engineering, Government Engineering College, Thrissur, in recognition of her exceptional contributions to chemical engineering education. With immense respect, with all the pride, I welcome Professor Dr. B. Lakshmikutti Amma onto this stage. Thank you, ma'am. Before that, we have Dr. R. Anjana, Honorable Head of Department of Chemical Engineering, Government Engineering College, Thrissur, who is also the former student of Dr. B. Lakshmikutti Amma, to introduce her. Ma'am, please.
Respected dignitaries on and off the dais, my dear teachers, dear students, a warm good afternoon to all. It's my proud privilege to introduce my dear teacher and a proud alumnus of this institute, Dr. Lakshmikutti Amma. Distinguished chemical engineer, Dr. Lakshmikutti Amma graduated in chemical engineering from this institute in the year 1979. She worked as engineer trainee in Kerala Financial Corporation and then joined as research scholar in Indian Institute of Science, Bangalore. She started her career as management trainee in FACT in 1982 and continued there up to 1985. Then she selected teaching profession by joining Government Engineering College, Thrissur as lecturer in chemical engineering in June 1985. She obtained her MTech in Chemical Process Control from University of Calicut and PhD from Department of Polymer Science and Rubber Technology, Cochin University of Science and Technology, Cochin. She served the Department of Chemical Engineering, Government Engineering College, Thrissur for more than 25 years and retired as professor and head of the department in the year 2013. During this long tenure, she contributed to the upliftment of department and institute with utmost sincerity and dedication. She was worked as adjunct professor from 2013 to 2015. In between, from 2001 to 5, she worked at Government Engineering College, Kozhikode as assistant professor when the college started and contributed significantly to institution building from scratches. She served as Chairman Board of Studies in Chemical Engineering, University of Calicut, Chairman Board of Examiners for BTech and MTech programs in Chemical Engineering, Biotechnology and Polymer Engineering of many universities. She has also been an expert member in committees constituted by Kerala State Pollution Control Board for specific issues. She is an active member of several professional bodies including Indian Institute of Chemical Engineers and Indian Society for Technical Education. Dr. Lakshmi Kutty Amma has published many papers in peer-reviewed journals and conference proceedings. She has also authored very popular books on topics like stoichiometry and process calculations, mass transfer theory and applications, and solution manual for stoichiometry and process calculations. A book titled Waste Management for Small Towns in Developing Countries will come shortly. I cannot conclude my introductory speech without saying a few words about Lakshmi Kutty ma'am's husband, late Dr. K.V. Narayanan sir. Narayanan sir served this institute as a well-known academician, a passionate teacher, and skilled administrator for more than 25 years. He authored the book Chemical Engineering Thermodynamics, which is a bestseller in India and abroad. He also co-authored the books Stoichiometry and Process Calculations, Mass Transfer Theory and Applications. Dear teacher, you and Narayan sir will always be fondly remembered with affection and gratitude by all of us. I welcome Dr. Lakshmi Kutty Amma to receive the Outstanding Chemical Engineer of the Year 2025 award. Thank you.
Thank you, ma'am. Now, moving on to the solemn part, we are now going to witness the conferring of the Outstanding Chemical Engineer Award 2025 instituted by IIChE Kochi Regional Center to Dr. B. Lakshmi Kutty Amma for her exceptional contributions to chemical engineering education. With immense respect, we invite Padma Shri Professor Dr. G.D. Yadav to present the Outstanding Chemical Engineer Award 2025 to Dr. B. Lakshmi Kutty Amma. We also invite Dr. B. Lakshmi Kutty Amma to step forward to receive the award. May I also kindly request all the dignitaries to join on this momentous occasion. May I kindly request everyone to rise and give a loud round of applause as we honor ma'am with the Outstanding Chemical Engineer Award 2025. Thank you, sir. Thank you, ma'am. Ma'am, we are eagerly waiting for you to express your feelings on this golden moment. Ma'am, please.
Respected Chief Guest of the Day, Professor Padma Bhushan, Dr. G.D. Yadav sir, who enlightened us with such an excellent talk and thought-provoking and inspiring to all the students. Our esteemed guest, PVS Namboodiripad sir, he was my examiner and he was in the interview board when I was selected, and his son was my student also. Dr. Professor Madhu. അത് അവിടെ കാണുന്നുണ്ട്. Professor Madhu, who is a wonderful organizer, a great professor, and he was the PhD guide for many of the faculty members of my department. Mr. Chandramohan, Professor, my dear student, my former colleague, and our principal, Solomon. Then Dr. Anjana, Manoj. A good afternoon to all of you. And the esteemed guests who are here, that is the IIChE members, my former faculty members, my classmate is here. He was the chairman of Heavy Water Board at BARC, and he's a friend of Professor Yadav, a friend. Then the present department faculty members, my dear students, though I have not taught you, you are. So I am happy and honored to receive this award. To be recognized by a professional body like IIChE is really great. And the occasion, the venue, the audience, all adds value to it. It's a pleasure to listen to Professor Yadav sir. I had once invited Professor Yadav sir for the Golden Jubilee of our department, Chemical Engineering department. Then we talked, it was not the time of social media. So we talked over phone and he said he will try to come. Then he asked me to send the details as an email. Then he told me his email, and that was wonderful. So even now I remember that email. He said, G.D. Yadav, don't do anything with that, it's a private. G.D. Yadav, G for God and D for devil. So I will never forget. So it is wit and wisdom combined. That is the type of person he is. So but anyway, he couldn't come for that function. We were eagerly waiting for him and he couldn't make it. Now you can understand how he can come. He is all over the world doing so much of work. So my thanks to IIChE Kochi for selecting me. And it happens that I think it's the first time a lady is honored this way. So that is a path breaking from the previous one. So I am always vociferous about recognition of the contribution of female folk in engineering. In any forum, I always talk about it because we were a neglected lot. I was born in the year 1957 in a very rural part of Kerala. Now, to us very rural, we used to say Kugramam in Malayalam. But now it is a very advanced town. That is the progress that Kerala is making. When I go to my place, I can't even recognize because of the roads and the bridges and all the buildings. Everything adds to the enhancement of that place. So, but that was not the condition when I was born there. And 1957 is a very special year. When we enter the college, it is written there, the college was started in the year 1957. It was started, there's a coincidence, it was started by the first Kerala ministry. The first election also happened in 57. The first Kerala ministry started the first government engineering college in Kerala state. So, and Kerala became so popular world over because a communist government came into power by people's ballot. And that was useful for me. That's why I am saying this here, why I should say it here. Because a person of my background could do schooling and dream of pursuing my interest just because of the education bill that was passed, where that is Sarvatrika Vidyabhyasam. Everybody can have school without paying any fees. So that was a groundbreaking bill. When I graduated also, it was a very funny area. It was the era of ladies need not apply. So while applying for a job, the last line, that is chemical engineering job only, the last line always states, ladies need not apply. So only no social media, newspapers only, and that too Hindu and Indian Express have to go and collect this, walking 2 miles or so to get the paper and go through the advertisement. It says ladies need not apply. So that was, you cannot say how you feel like that. When I dreamed of working as a chemical engineer, and I wanted to be an engineer in a firm itself. Not, I didn't consider teaching at that stage. So that was how I grew up, how I got into a job and all that. So now times have changed. After starting my career as a teacher, my focus was always in helping the undergraduate students in building a strong foundation in the fundamentals of chemical engineering. I could do it while teaching because of my background in industries like where exposure to all possible chemical processes were there. Then my research background at IIChE and the training that I got when I worked as a trainee in Kerala Financial Corporation, which financed small and medium industries. So I had an overview of all the things, financial, then small industry, medium industry, then large industry, that is a pioneer industry, they started from wood gasification, producing ammonia that way. So everything was in it. So I was very confident as a teacher, and I tried to enlighten the students with it. So the books and all were concentrated on the fundamentals. So my belief is that a thorough understanding of the fundamentals will enable the students to branch out in any field, let it be in production, design, services, research, academic, and so on. Because the basic balance, what is the carbon dioxide problem? The first thing is the carbon that is there. You cannot convert it. That atom carbon will be as carbon. Whether it goes into air, it goes into soil, or it's in the plant. So if you have that basic understanding, you can solve so many problems. I am grateful to my husband for making everything possible. Due to our shared interests, his brilliance and hardworking nature, and taking me along in everything academic or non-academic. It was a great partnership. To the students assembled here, my advice is, pursue your dreams. The opportunities are unlimited. Now the gender bias has also narrowed. And Professor Yadav sir has given you what all came. The coming era is for the chemical, the life on earth that is upon the hands of the chemical engineer. So plenty of opportunities for you children. This award gives me strength to pursue my interest in chemical engineering further. Thank you all.
Thank you, ma'am, and congratulations on your achievement. Maybe take this opportunity to let everyone know here that your books have always been the Bible for the chemical engineering students, and it will continue to be so for the future students too. Thank you, ma'am. We now move to the presentation of mementos as a mark of gratitude. First, we invite Dr. P.V.S. Namboodiripad to present a memento to Padma Shri Professor Dr. G.D. Yadav. Sir, please. Next, We invite Professor G.D. Yadav to present a memento to Dr. P.V.S. Namboodiripad. We now request Professor Dr. G. Madhu, Chairman IIChE Kochi Regional Center, to present a memento to Professor Dr. P. A. Solomon, Principal, GC Thrissur. Next, we invite Secretary of IIChE, Sri Chandra Mohan Sir, to present a memento to Dr. Anjana, HOD, Department of Chemical Engineering, GC Thrissur, and to Professor Manochan. Thank you, sir. To conclude today's ceremony formally, I invite Professor Manochan for delivering the vote of thanks.
Respected dignitaries, distinguished guests, faculty members, and my dear students. Good afternoon to one and all. It is my great privilege on behalf of Government Engineering College Thrissur and the IIChE Kochi Regional Center to propose the vote of thanks on this remarkable occasion, the Golden Jubilee celebration of IIChE Kochi and the Golden Jubilee lecture delivered today. First and foremost, I express our profound gratitude to our esteemed chief guest, Padma Shri Dr. G.D. Yadav, for delivering an insightful and visionary lecture on towards a net negative future sustainability, climate action, and the hydrogen economy. Sir, your presence has truly elevated the dignity of this celebration, and your thoughts will continue to inspire our students and faculty alike. Our heartfelt appreciation and thanks also goes to our guest of honor, Dr. P.V.S. Namboodiripad, first Keralite National President of IIChE, for gracing this occasion and sharing words of wisdom. I extend our sincere thanks to Dr. G. Madhu, Chairman IIChE Kochi Regional Center, for his dedicated leadership, guidance, and for spearheading this grand event with great enthusiasm. Thank you, sir, for your support and for bringing the Golden Jubilee celebration to our campus. A special and respectful acknowledgement due to Professor Dr. B. Lakshmikutti Amma, was my teacher, was my HOD, whom we had the privilege of honoring today with Outstanding Chemical Engineering Award 2025. Madam, your exemplary contribution to the field of chemical engineering continued to inspire the generation, and it was indeed a moment of pride for all of us to honor you. Our sincere thanks to Professor P. A. Solomon, Principal Government Engineering College Thrissur, for his unwavering support, guidance, and encouragement in hosting this prestigious event in our campus. So I am grateful to Dr. Anjana for his meaningful introduction to Dr. Lakshmikutti Amma, and Sri Chandra Mohan, Secretary IIChE Kochi Regional Center, for his devoted efforts, constant consideration in making this program a success. I also extend heartfelt thanks to all other dignitaries. So many stalwarts of chemical engineers are sitting here, including faculty members, invited guests, and well-wishers who have joined us today. A program of this scale successful only through the collective effort of many hands. I thank all the faculty members, non-teaching staff, and especially the student community of the Department of Chemical Engineering for their tireless work, discipline, and dedication in organizing and coordinating every detail with precision. To all participants, attendees, and well-wishers, your presence has added grace and meaning to this important milestone in the journey of IIChE. Finally, I would like to thank each one of you seated here today for being the part of the celebration and for making it truly memorable. Thank you all once again, wishing you a pleasant and inspiring evening ahead. Thank you.
Thank you, sir. As we come to the end of this memorable and historic celebration, let us carry forward the spirit of innovation, excellence, and service that IIChE has upheld for 50 glorious years. Now, I request everyone to kindly stand for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Once again, thank you all and wishing you all a wonderful evening.